The purpose of the anti-lock brake system, or ABS, is to prevent lockup of the wheels during an emergency stop. This is achieved by modulating the hydraulic pressure sent to the front and rear brakes. ABS helps the driver maintain steering control and, under most conditions, bring the vehicle to a stop in the shortest possible distance. During normal non-ABS braking events, the addition of ABS is transparent to the driver. The amount of brake pedal force required to engage the ABS function will vary with road conditions. Brake lockup is more likely to occur on a wet, snow-covered, or icy road, or as a result of a sudden reaction by the driver due to an unexpected obstacle. During some braking situations, the wheels may lock up. If the wheels lock up, the vehicle may start to skid, resulting in complete loss of driver control. To prevent this from occurring, the ABS system will take action. Many ABS systems include a traction control or TC function that helps maintain vehicle traction during acceleration and driving. Traction control uses the components of the ABS system to control a vehicle's wheel spin during acceleration. Traction control equipped vehicles have an additional inlet isolation valve in the HCU. The operation of anti-lock brake systems is controlled by a microprocessor called the Anti-Lock Brake Control Module, sometimes referred to as the Electronic Control Unit, or ECU. The ABS control module receives speed readings from each wheel via a wheel speed sensor and processes this information to determine if ABS operation is necessary. The ABS control module continuously monitors and compares the rotational speed of each wheel, and when it detects an impending wheel lock, it modulates brake pressure to the appropriate wheel. When an ABS-controlled wheel looks as if it's going to stop rotating, the ABS control module sends electronic signals to the HCU to release brake pressure to prevent lockup. When the brakes are applied during normal braking, fluid is forced from the master cylinder to the normally open isolation inlet solenoid valves of the HCU. The brake fluid travels uninterrupted through the HCU to the wheel brake. When the brakes are applied hard enough to cause a wheel lockup, the ABS control module uses wheel speed sensor input to determine which wheel is locking up. Then, using this input, the ABS control module sends a signal to the HCU, which activates the inlet isolation valve for that wheel. The inlet isolation valve closes, preventing additional hydraulic pressure from reaching that wheel. The ABS control module then looks at the wheel speed signal again. If the affected wheel is still decelerating too quickly, the control module sends a signal to the HCU that opens the dump outlet valve for that circuit. This releases pressure from the brake to the accumulator. These actions are repeated until the wheel is no longer in danger of locking up. The valves may cycle as many as 15 times per second. Since brake fluid is displaced each time the outlet dump valve is opened, there must be a way to replenish the brake fluid to the master cylinder. This is accomplished by using a pump motor assembly. When the pump and motor assembly is activated, brake fluid that is stored in the accumulator is pumped back to the master cylinder. On certain models, the ABS control module also controls electronic brake distribution, or EBD. With the use of the ABS components, this feature controls rear brake pressure and acts as an electronic proportioning valve to prevent rear brake lockup. Traction control uses the components of the ABS system to control a vehicle's wheel spin during acceleration. Some HCUs have an additional traction control inlet isolation valve. Other HCUs utilize existing ABS isolation inlet valves. On traction control-equipped vehicles, the ABS control module monitors the wheel speed sensors to determine if a drive wheel has lost traction. If the ABS control module senses wheel spin, it closes the traction control inlet isolation valve, isolating the hydraulic circuits of the drive wheels from the circuits of the non-drive wheels. The ABS control module then activates the pump and motor assembly to send hydraulic pressure to the brake circuits of the drive wheels. This applies the driving wheel's brake units, slowing the rotation and maintaining traction. The system will continue to cycle until the ABS control module determines that the tires are no longer in danger of losing traction, or until the maximum brake application speed limit is reached. Traction control operation stops if the brakes are applied. If used continuously on icy roads, traction control may be disabled by the ABS control module to prevent overheating of the brakes. The ABS control module interacts with the PCM to reduce engine torque if the drive wheels lose traction and begin to spin during acceleration. Some traction control systems reduce the throttle opening, injector pulse width modulation, and/or retard vehicle timing to control wheel spin.